We humans often like to think that, thanks to our advanced technology, we know nearly everything about our solar system. But scientists say this assumption couldn't be more wrong. There may be billions of interstellar structures within our solar system, and they remain unrecognized, undetected, and unknown. These new and shocking findings were brought into the spotlight by an unexpected visitor from an alien world, Oumuamua. In 2017, the interstellar object named Oumuamua entered our solar system and attracted worldwide attention with its sudden appearance. This cigar-shaped celestial body was discovered by researchers using the Pan-STARRS telescope in Hawaii, which scans the skies for asteroids and comets. Initially, Oumuamua was identified as the first known interstellar object to visit our solar system, sparking excitement and curiosity among astronomers. However, this assumption is now being questioned. Recent discoveries suggest that Oumuamua may not have been a singular, unique object, but rather one of many similar structures that could exist in our solar system, possibly numbering in the hundreds, if not billions. Oumuamua's strange behavior baffled scientists from the moment it was discovered. Unlike typical asteroids or comets, which move in predictable orbits along the gravitational pull of larger celestial bodies, Oumuamua took an unusual, erratic path. It sped across the solar system as if it wasn't bound by the same laws of physics that govern other objects. Asteroids and comets generally follow well-defined trajectories due to gravitational forces, but Oumuamua seemed to defy these expectations. Its behavior raised the question, could this object have come from a different world, governed by entirely different forces? While its movement and shape already set Oumuamua apart, scientists found its physical properties equally puzzling. Unlike comets, which emit gas and dust as they approach the Sun, or asteroids, which tend to have predictable structures, Oumuamua displayed no signs of gas emissions or a dust mantle. It appeared to be a smooth, metallic object, with scans revealing an unusually high proportion of metals. The cigar-shaped body, approximately 1,000 meters long, looked more like a polished object than the rocky asteroids we are familiar with in our solar system. This mixture of characteristics led some researchers to speculate that Oumuamua could be more than a natural object. It could potentially be an advanced piece of technology, camouflaged as an asteroid. The question loomed, was this object a cleverly disguised interstellar probe? Avi Loeb, a prominent researcher at the Harvard-Smithsonian Center for Astrophysics, put forward one of the most intriguing theories about Oumuamua's true nature. Loeb was particularly puzzled by the object's unusual acceleration and its ability to make sharp turns, both of which were unprecedented in any known asteroid or comet. These movements suggested that Oumuamua was utilizing a previously unknown form of propulsion, unlike anything ever observed in celestial bodies. Loeb and his team proposed that Oumuamua could have been accelerated by the reflection of solar radiation, a natural process known as solar sailing. While this idea may seem plausible on the surface, it raises a deeper question: could there be an advanced technology behind this behavior? If so, the implications would be extraordinary, suggesting that Oumuamua may be the product of an extraterrestrial intelligence far more advanced than our own. Adding to the mystery was Oumuamua's appearance. Unlike typical comets or asteroids, it emitted no light and reflected very little sunlight. Color scans revealed a dark reddish-brown surface, similar to certain objects in the Kuiper Belt, a distant region of our solar system. Yet, despite its appearance, the object exhibited none of the typical characteristics of celestial bodies from that region. Its rapid movement, combined with its strange composition, left scientists with more questions than answers. Perhaps the most alarming discovery to emerge from the study of Oumuamua was the realization that our solar system may be teeming with similar interstellar objects. Loeb and his team examined other near-Earth objects, asteroids, comets, and small rocks, and found structural similarities between these objects and Oumuamua. Could these small objects also be interstellar visitors, silently passing through our solar system without being recognized? If this hypothesis is correct, the implications are staggering. Our solar system could be filled with interstellar objects and structures that have gone undetected simply because they are too small or too far away to be observed with our current technology. There could be billions of such objects, with Oumuamua merely being the first to catch our attention. Scientists now believe that objects like Oumuamua may not be rare at all, and we've simply lacked the tools to detect them. If these objects are as common as researchers now suspect, it raises the possibility that our solar system is far more dynamic than previously believed. We may be surrounded by interstellar debris, some of which could be natural, while others could represent technology from distant worlds. While Oumuamua has captured much of the public's attention, it is not the only mysterious object in our solar system. Giant comets, many originating from the Oort Cloud, represent some of the most fascinating and enigmatic celestial bodies we have observed. These icy travelers often pass by Earth, leaving behind spectacular tails of gas and dust as they approach the Sun. The Oort Cloud is a hypothetical region far beyond the orbit of Neptune, where billions of comets and other icy objects are thought to reside. This vast, spherical cloud contains remnants from the early formation of the solar system, and it is believed that gravitational forces from passing stars occasionally dislodge these objects, sending them hurtling toward the inner solar system. Some of the largest comets, like Halley's Comet and C/2011 KP36, have provided stunning displays as they pass close to the Sun. Halley's Comet, which has an orbital period of about 76 years, was last seen in 1986 and will make its next appearance in 2061. C/2011 KP36, discovered in 2011, measures nearly 50 kilometers in diameter, dwarfing Halley's Comet. These celestial giants offer a glimpse into the distant past, as their icy cores contain material that dates back to the early solar system, but the true giants among comets are even larger. C/2002 VQ94 and C/2014 UN271, discovered in 2002 and 2004 respectively, are among the biggest comets ever observed, with diameters of 100 and 160 kilometers. These massive objects originated from the outer regions of the solar system, and it remains uncertain whether they will ever return after their brief visits. The Oort Cloud remains one of the greatest mysteries in astronomy. Although no spacecraft has ever visited this distant region, scientists are confident of its existence based on the trajectories of long-period comets. The Oort Cloud is believed to be a vast sphere of icy objects, remnants from the formation of the solar system, that extends far beyond the orbit of Neptune. Gravitational disturbances, perhaps caused by nearby stars, occasionally send chunks of material from the Oort Cloud on a journey toward the inner solar system. As these objects approach the Sun, they heat up, releasing gas and forming the iconic tails that make comets so recognizable. Unfortunately, the Oort Cloud is so far away that we currently have no means of sending probes to study it. Even the Voyager spacecraft, which have already traveled beyond the edge of the solar system, would take hundreds of years to reach the Oort Cloud. Nevertheless, the objects within this distant region continue to shape our understanding of the solar system's early history. Another group of celestial bodies that have sparked fascination among astronomers are the Trojan asteroids. These unique objects occupy the Lagrange points in the orbits of planets, where gravitational forces from the Sun and the planet create stable regions. Trojans share their orbits with larger planets, following the planet or, in some cases, leading it. Jupiter is particularly known for gathering a significant number of Trojan asteroids in its orbit, but Trojans have also been found in the orbits of Mars, Uranus, and Neptune. These asteroids are named after famous warriors from the Trojan War, continuing the tradition of naming celestial bodies after mythological figures. Unlike the dynamic comets that race through the solar system, Trojan asteroids remain in stable orbits, bound to their host planets by the gravitational balance of the Sun and the planet. Some of these objects may have been orbiting their planets for billions of years, locked in a delicate cosmic dance. In the coming years, NASA's Lucy mission, launched in 2021, will provide a closer look at some of the most important Trojan asteroids in Jupiter's orbit. This mission aims to shed light on the composition and origins of these objects, helping scientists understand the history of the solar system. As we uncover more about Oumuamua and other celestial visitors, it's clear that our understanding of the solar system is still in its infancy. With billions of potential interstellar objects lurking within our own cosmic neighborhood, many of them might pass by us unnoticed. From mysterious comets in the Oort Cloud to the stable Trojan asteroids, there is so much more to discover. As technology advances, missions like NASA's Lucy probe and further studies of interstellar objects will provide more insight into these unknown realms. Perhaps Oumuamua is just the beginning of an exciting era where the secrets of the universe start to reveal themselves to us, one interstellar visitor at a time.